Hello, and we're back with Hocus Focus. Today we're going to be looking at circles rather than the substitution that I originally had planned for today, because I received a message from God saying that someone wanted this video. So I'm going to go ahead and try to draw a circle here. That one's okay, but we're going to pretend that it's a real circle. Just like we're going to pretend that this is a 45-degree angle. Alright, radius of 1. So this is a circle, and this is the center. This is obviously not drawn to scale. But it gives us a pretty decent visual aid. Alright, so this is going to be a bit of a more basic video. It's probably going to be about ACT level, but this is still something that could get a little bit complicated if you're not used to this kind of thing. So if you're either rusty or you hadn't been paying attention as much as you should have, this might come in a little handy. Then otherwise it might just be I don't know, late night study ASMR or something. I don't know. Alright, at any rate, so the normal area of a circle is equal to pi r squared. And in this case, that obviously just comes out to pi, since 1 squared, the radius is just 1, so that comes out to pi. Now, the area that we want to look for is this one, though. And now that we have these pieces in place, it's actually a little bit easy. You see, the area of this is exactly the area of the ratio from the amount of this amount of degrees to the total amount of degrees in a circle, or 360. So if we have something looking like, area inside the angle area of the circle, we have that ratio is equal to 45 over 360, and this is equal to pi. So we can just say or pi over 8. So now that that's out of the way, let's make this a little bit more complicated. Let's say we want to find, rather than the area inside this angle, we want to find this area right here. Now, obviously we have a triangle right here, so we're gonna start off with that. So I'm going to take the triangle and I'm going to move it out just so that we can examine it a little bit more detail. Alright, so we have our triangle on the outside. We just need to find the area of this triangle so that we can subtract the area of the triangle from the area of the inside of the angle. And that'll give us the angle of the outside portion right here. So I like equations. Let's just write something out explicitly. Alright, so we just need to find out what the area of the triangle is. And to do that, I'm just gonna crack that apart. This angle is 22.5 degrees. Hypotenuse is still 1. We just need to find the opposite and adjacent legs. But we actually have a shortcut around that if you're comfortable at all with trigonometry. So sine and cosine are equal to the ratio of the opposite or the adjacent in order of to the hypotenuse. So rather than just find these guys explicitly, we can just say the area of this triangle is equal to don't forget degrees. And let's actually, rather than use T, let's use an actual triangle. Alright, so that's the angle of that. However, since we're actually finding 2, let's just ignore this. And this is the area of our triangle. Now, I did the math for this portion a little bit ahead of time. That comes out to about 0.354. And the angle of the inside here, pi over 8, that actually comes out to pretty close to about 0.39-ish. So the area of the outside, or of this portion right here, is equal to about 3.9 minus 0.354, which in turn is equal to, let's see, that'd be 6 and then 3. Actually, it's not. 0.036. Yeah. All right, so I hope that was pretty quick. I hope it was at least entertaining. And if nothing else, maybe it gave you some other questions to ask down in the comments, or other comments that you would like to make about general video quality, or what you would like to see covered next. But beyond that, this was Hocus Focus, and I hope you have a wonderful day.